Hello again. Today we're going to be talking about estimating probabilities by using two-way tables. So let's talk about what those are. It's basically an organizational mechanism for you to organize everybody in a population or everything in a population by two variables. And we can put those variables in categories, and then we use that table to find probabilities in different ways. You just have to make sure that when you're creating your table, everybody in the population is only represented once. All right, so we're going to create the table and put the possibilities for one category across the top and the possibilities for the other category along the left-hand side. So let's look at an example of that. I asked a group of 150 juniors and seniors what they drank first thing in the morning was, and they gave 4 answers: coffee, tea, soda, and water. And so what I did was I listed the juniors and seniors in that left-hand column, and I listed the possibilities for what they drank in the morning along the top. And I also added an additional column and row for the totals of each category. So as you can see, there were 72 juniors, there were 78 seniors, and then along the bottom, you can see that 82 students drank coffee, 10 drank tea, 31 drank soda, and 27 drank water. And no matter whether you add up the totals in the last column or the last row, you should get a total of 150 because that's the total population that was asked. So you'll want to verify that before you start calculating probabilities. So let's estimate some probabilities. The first one I want to know is if a student is a junior, what is the probability that they drink soda? So since I'm only talking about the juniors, I'm going to focus my attention on the first row, which only deals with the juniors, and there are 72 of them. Out of that 72, 18 drink soda. So the probability that a student who is a junior drinks soda would be 18 out of 72, which is 0.25. Now let's estimate the probability of someone that I know is a coffee drinker. What's the probability that they are also a senior? So now I'm focusing my attention on the first column, which talks about the 82 coffee drinkers. So out of those 82 coffee drinkers, how many are seniors? Well, the table says that that's 45. So the probability that someone who is a coffee drinker is also a senior is going to be 45 out of 82. As a decimal, that's going to be approximately 0.549. And then finally, what's the probability that any student in this population of 150 is a junior that drinks tea? So now I'm focusing at the entire table, all 150 students, and I want to know how many of those 150 students are juniors that drink tea. Well, that's only one cell of the table, and that's the one that has the 6 in it. So that means the probability of any student in that group being a junior who drinks tea is going to be 6 out of 150, which is 0.04. So this is just a way to organize the data so that it's easier to figure out probabilities if you want them. If you have any questions about that, please let me know, and I will see you tomorrow.